Exercise 6.1, problem 13, discussion. The internal bisector of angle A of triangle ABC meets BC at D, and the external bisector of angle A meets BC produced at E. Prove that BD by BE equal to CD by CE. It looks very difficult, but don't worry. The moment you draw a figure, half the problem is solved. So let's draw a figure for this problem. So there is a triangle ABC, right? First draw this triangle ABC. Then what else you are saying? Okay, and the internal bisector of angle A meets BC at D. The internal bisector of angle A, which is AD, meets BC at D, right? So it meets at this point. So AD is the internal bisector of angle A. So these two are equal. That's why it's marked by this symbol, right? And then at the same time, the external bisector of angle A meets BC produced at E. So this is BC. You produce it a little longer, and you will be able to meet the external bisector of angle A. See, this is internal angle of A, and this is external angle of A. So the bisector external external bisector of angle A meets BC produced at point E. Right now it becomes a little easy. So you have to apply the internal bisector theorem for this triangle ABC, and you have to apply the angle bisector external for the triangle AB and ABC, but ABE also, E will also come into play. Right, so keep that in mind. Let's work it out. So what are we given? We are given the internal bisector of angle A, and we are also given the external bisector of angle E, and the points where which it meets BC or BC produced. We are asked to show this equation, that BD by BE equal to CD by CE. And the formula or the hint is angle bisector theorem. So first draw the figure and mark the given information on it. So what's the information? That these two angles are same, is a bisector, so these two are same and these two are equal, right? Now apply angle bisector theorem for triangle ABC. For triangle ABC, and AD is the angle bisector of angle A. So what does it mean? AB by AC will be equal to BD by DC, right? Now apply angle bisector theorem for triangle ABC for angle A external. Okay, now again you apply the same thing for ABC, but for angle A external. So external angle is this angle altogether, and AE is bisects the external angle, and it meets BC produced at point E. That's what it is told, right? So which means AB by BC will be equal to BE divided by CE. See, had it been inside, they say if the point is inside, what would you do? AB by AC will be equal to BE by EC, right? The same principle has to be applied for external also. So AB by BC will be equal to BE, and divided by, instead of CE coming this direction, we just go the opposite direction. So divided by CE. That's all it is. Okay. So you get AB by AC equal to BE by AC. And you see LHS of equation 1 and 2 are same, which means RHS also will be equal. So RHS BD by DC will be equal to BE by EC. Then what you have to do, you'll have to rearrange them a little bit, and you'll get the required equation. You got it? So please pause the video here and try to work this problem on your own, and on completion please come back and check your working against our solution. Okay, the solution. So in the triangle ABC, the AD is the internal bisector of angle A, and AE is the external bisector of angle E. So you'll have to apply the angle bisector theorem first for the internal bisector, for the AD, which is internal bisector. So we'll get AB by AC equal to BD by DC. That is what we have here, right? Now let's apply the same for the external bisector of angle A. That is AE is the angle external bisector. So it will be again AB by BC, because AB by BC are the two sides which contain the angle A, right? Is equal to BE divided by CE. So that is equation 2. And you can see LHS of both the equations are same, which means BD by DC equal to BE by EC. Now you can rearrange this. So BE comes down and take this DC up. So BD by BE will be equal to DC by EC. And what is DC? DC is CD. And EC is CE. This is the required equation which you have to prove. You got it? So all you have to do is that apply the internal bisector for the triangle ABC. Okay, and the same external bisector of angle A for the triangle ABC. You will get two different equations, and you will be able to see the LHS in both the cases will be the same, and equate the RHS and simplify, rearrange it to get the required equality. Okay, so I hope I made it easy for you. If not, please go through this problem one more time. Okay, the only point which will be little difficult to understand is that how do you get this external ratio. So for when this external angle is, this is external angle A, right? In which, and AE is the bisector, in which case AB by AC will be equal to, so imagine this E is inside. So what will you say? BE by EC if it is internal. Apply the same process. So BE divided by, you'll say EC, right? So that is nothing but CE. Or you say EC also, that's no problem. BE divided by EC. Finished. Okay. So thanks for watching this video.